Hi, my name is Hong Qin. I'm a faculty of computer science and biology at the University of Tennessee at Chattanooga. Today, I will use a small example to explain how we can make a computer program run faster. A computer program can be considered a software solution to solve a problem. So today, the example I'm going to use is to find a missing card in a deck of poker. Here is a set of a poker card. I took a card out of this. And if we want to find out which card is missing, we have to go over all those cards and then trying to figure out which card is missing. The key idea here is this is randomly shuffled data. This is unorganized data. What I took is this diamond or king. But if I don't tell you, you have to go through all these cards trying to figure out which one is. Now, how do we make this? This is search problem in computer science. How do we make this much faster? How can we solve this problem much faster? So there's another way to do this. And in this case, we are going to organize the card by the color and by its order. So this is now what we call the organized data. And in this case, I'm going to also take a card out. Now, if we want to look for which card is missing, we first can tell from the color one of them is thinner than the other deck. So from one of the four, we can identify one of the color is missing. And then we can go through this color of the deck to see which card is missing. So because I'm organizing this card from the smaller one to the largest one, I can tell there's one card is missing here. So in this case, the worst case scenario is 4 color plus 13 step, so 17. So for the organized data, we need 17 steps to find it. But for the unorganized data, when the data is unorganized, this set, we actually need 52 steps to identify the missing card. So if I'm going to share my screen. So the idea is, how many steps do we need to find a missing card? In the first situation is a random set, and the worst case scenario is 52 steps. In fact, in this case, the best case, the average case, and depending on how we search, it can also be 52 steps. In the second situation, we have organized data. And the worst case scenario, we will be from 4 color out of 1, we have 4 steps. And then there are 13 numbers we go through. In the worst case scenario, if the K is the last one, and that would be 13 steps. And then, so 4 plus 13, we have 17. That's the last, the worst case scenario. And on average, in this case, we may go through 2 of the color average, and then if we average 6 or 7 steps in the middle, so the average step here is 8 or 9. We could actually have an even faster way to find the card. In this case, in computer science, we can use something called indexing. In this case, we can put a color into a coding scheme. We can say spade, heart, diamond, and club. We can give it a number. Say spade is 0, heart is 1, diamond is 2, club is 3. And then the card we still use is a number. And then we just put all the cards in a line. And those lines are going to have positions. And how do we decide those positions? The position will be decided by, say, color times 13 plus the number. So if it's say a heart of a diamond, heart of a king, and the position will be the heart is 1, so we have 1 times 13 plus 13, it will be 26. And then we just go to the 26th position in the line, that should be the heart of the king. And so this, in this case, this will be much faster. And this is the idea called the indexing. And this is also organized. In fact, this is a sorted list, organized data. Okay, so I hope this, you found this example interesting. I hope you want to pursue computer science as part of your career path. Notice this problem-solving skill is not just in computer science. You could apply it in many other career paths. Computing has been pervasive in almost every aspect of our life and career. So learning how to do computing will be beneficial to your career perspective. I hope this is useful.